All right, our last lesson that we need to do in this unit on solving systems of equations is going to be solving systems of equations using addition and subtraction. Addition is going to be from digits 6.5 and then subtraction will be 6.6, but we're going to do them together because they're really similar. So you can put the table of contents, the title is going to be solving systems of linear equations using addition. Go ahead and say and subtraction because that's going to be the second little lesson we're going to do in the same set of notes. And then on the next clean sheet of notebook paper, your title is Solving Systems of Linear Equations Using Addition and Subtraction. And then the EQ is How can I use addition and subtraction to solve a system of equations? Hit pause and set up your notes. When you're ready to move on, hit play. All right, go ahead and copy this down. How do I solve a system of linear equations through addition? You can solve linear equations using an algebraic method called the addition method. In the addition method, you solve the system by adding the equations to eliminate one of the variables. This is really fun. Just like the last lesson, I think this is just super fun. I hope you feel like that as well. So we're going to line up the equations, and we want to kind of line it up so that the same variables are vertically up and down from each other. I'll show you what that means in a second. And then when we add the equations together, you should have them either the x's or the y's are going to be additive inverses that kind of like cancel each other out so that leaves you with just one variable left over. If you haven't finished copying this down, hit pause and finish copying. When you're ready to move on to an example, hit play. Okay, so this is what I was talking about. Here we have two different equations. I'm not going to make you copy this example because we're going to do one together in a second, but I do want you to copy each of the steps. I have a step per slide. So step 1, solve for the first variable, write that down. And if you look at this system, we see that we have the x's on top of each other, and we have the y's on top of each other, and then we have the constants over here. Now notice that we have plus 1y, and then we have minus 1y. Those are additive inverses, and so when I put those together, guess what's going to happen? They cancel each other out. And it's so beautiful that that happens because look what that leaves us with. We add 1x plus 3x together. We're just adding straight down, and we get 4x. Y minus y is 0, and then negative 1 plus 5 is 4. We can get rid of the 0 because of the additive identity property. And then 4x equals 4, so x equals 1. Once we know what x is, step 2, copy the step, you can solve for the second variable. So we go back and we plug in x equals 1 for x. And that helps us solve for y. So I would subtract 1, we'd get y equals negative 2. And then step 3, write the solution. Since x is 1, y is negative 2, here's our solution. Hit pause and copy step 2 and step 3 if you haven't already done that. When you're ready to try an example, hit play. Okay. Now, is the addition method a good choice for solving the system of equations? From looking at it, I see that I do have negative x, and those are additive inverses. So I know that when I decide to add the equations together, pen's not writing, shocker. When I decide to add the equations together, what would happen with these? They would cancel each other out because they're additive inverses. And that would just leave me with 3y equals 12, so we would get y equals 4, and then we could plug that in to solve for x. So yes, the addition method is a good choice here because I see this right here, that those would cancel out. So now, let's try one. Solve the system of equations by addition. Now, looking at this system of equations, let me real quick do this because I think that's going to get my pen to work. Let's see. I see that the x's, no, but the y's, aha, I have additive inverses there. So when I add the second equation and the first equation together, I get 2x plus 6x is 8x. So here we go. By the way, do this in your notes. This is example 1. I do want this one in your notes. 2x plus 6x is 8x. 5y minus 5y is 0. So those go away. I could put a 0 if I wanted to. And then 17 minus 9 is 8. Oh, that's so nice. Isn't it so nice? So now I can just quickly solve for x. And I get x equals 1. Now, step 2, I'm going to pick an equation. Doesn't matter which one. I'm going to go with the first one. going to write. So now, let's try this again. 2 times 1 plus 5y equals 17. I took what I got right here for my solution and I plugged it in for x. So 2 times 1 is 2. Oh my goodness. My board is just having a hard time. One more time. Okay. 2 times 1 is 2. Hello. Plus 5y equals 17. Now we have a two-step equation, so I subtract 2 on both sides. Cancel. 5y equals 15. So then y. Oh my goodness. That says divided by 5. Okay. Y equals 3. So if I were to write my answer as an ordered pair, x is 1, y is 3. If I were to graph those two equations on a graph, that point is where the lines would cross. Wasn't that fun? Let's try another one. Example 2. Everybody do this with me in your notes. Call it example 2. And again, I look at it and I see my x's are my additive inverses here. Yay! So those are just going to cancel out. And then I have 2y plus y would be 3y. And then 10 minus 16 is negative 6. So beautiful. Look at those x's canceling out. Remember, that's called the addition method. So then we divide by 3, and we get y equals negative 2. Now we need to find what x would be. So I take my first equation. I could also do my second equation if I was feeling spicy. I don't know. And my board's not writing again. So that should say 10. So I've taken my y equals negative 2 and I've plugged it in for y. And this should say, I'm lost, there we go, 10. Okay. 7x, and then 2 times negative 2, that would be negative 4. Negative 4 equals 10. So I'm going to add 4, I get 7x, cancel, equals 14. So divide by 7, x equals 2. So my ordered pair for the solution would be x is 2, y is, that's a negative 2. Okay, so that's the addition method. Let's now try the subtraction method. The subtraction method is very, very similar to the addition method. And go ahead and quickly copy this down. How do I solve a system of linear equations through subtraction? Just as you can use addition to solve systems of linear equations, you can also use subtraction. In the subtraction method, you solve the system by subtracting the equations to eliminate one of the variables. So instead of adding the from top to bottom the two equations, we're going to subtract. And we're trying to achieve the same purpose with this. We're trying to get one of the variables to cancel out. So like if I had 5x in the first equation and then 5x in the second equation, I can't do the addition method because if I did 5x and 5x, that gives me 10x. But if I did the subtraction method, 5x minus 5x would cancel out, and that would be more helpful to me. Okay, so let's look at an example to see what I'm talking about. Here, we see 1x and 1x. We don't want to add those together because that would give us 2x. But if we subtract the second equation from the first equation, 2x minus x gives us 1x. Y minus y goes away. And then 10 minus 7 gives us 3. That helps us find what x is. Again, the second step, we plug that in. And from here, it's just the same process. We get our y, and then we write our solution as an ordered pair. So let's try one. Call this example 3. Call this example 3. So, I see that I have minus y and minus y in both equations. What I'm going to do is subtract the second equation. So I'm going to change the sign of each of the parts of that second equation. Why would I want to do that? Because when I change the sign of each of the parts of the second equation, now I have minus y and plus y, which is exactly what I need for them to cancel out. So now I'm going to do 3x minus 2x and get 1x, or just x, minus y plus y, additive inverses, they cancel, and then 4 minus 1 is 3. And And wow, that was nice. I didn't even have to do any extra work there. They gave me x equals 3. So now to find y, I plug in 3 for x. And I'm going in the first equation, but either one would work. And that's 9 minus y equals 4. So then I subtract 9. And those cancel. I have negative y equals, that would be negative 5. So if negative y equals negative 5, that means y equals 5. So my solution would be x is 3, y is 5. That's example 3. Let's try example 4. I hope y'all are having fun with this like I am. Okay. You don't have to be sarcastic. I heard your thoughts. Okay, here we go. Look at this system of equations. I see 3x and I see 3x, so I know that if I subtract the second equation, that's going to take care of the x's and make them go away because they're additive inverses. 3x minus 3x is 0. 4y minus 2y would give me 2y. And then 20 minus 16 is 4. So then I just divide by 2, and y equals 2. Now to find x, I'm going to plug in 2 for y. So 3x plus 4 times 2 is my y value, equals 20. So then 4 times 2 is 8. Then I'm going to subtract 8 from both sides. Those cancel. 12, divide by 3, divide by 3. X equals 4. Okay, so my ordered pair, x is 4, y is 2. Bada bing, bada boom. So if I graphed these two equations, they would intersect at this point, 4, 2. Okay, at this point you should be ready to try the digits. 6, 5 is all addition. 6, 6 is all subtraction, where you subtract the second equation from the first. Have fun!